Okay, so good morning, doctor and respected examiner. My name is Feng, and today I'll be presenting my PSM1 project, the NetGuard Network Vulnerability Scanning and Risk Assessment System. So this project is supervised by Dr. Johan bin Mohamed Sharif. So for this presentation, I will go through five main sections, and the first I will start with the introduction, and next I will move on to the literature review, and the third one I will explain the system development methodology used in this project, and the last one I will end with the conclusion and future work for PSM2. So I'll begin with the chapter 1, which is the introduction. So the main issue that motivates this project is that many Soho users, which means small office and home office users, do not have clear visibility of their local network security condition. And in many cases, they may have several devices connected to the same network, such as laptop, smartphone, and also IoT device. And however, there are existing channels are already available, but many of them are too technical, costly, or complex for non-expert users. So, for example, some tools may show raw results such as port number and service version, but this output can be difficult and understand if the user does not have a strong cyber security background. So, based on the problem mentioned earlier, the aim of this project is to develop a lightweight web-based network vulnerability scanning and risk assessment system. So the system is designed to help Soho users identify possible risks in their local network and understand what action they can take to reduce those risks. So to achieve this, and there are four main project objectives. So the first objective is to analyze the needs of non-expert users, non-expert Soho users in small-scale network environments. And the second objective is to design the system architecture by integrating NMAP, CBSS, and the MVD API. And the third objective is to create the NetGuard using Python Flask together with a remediation recommendation engine. And the final objective is to evaluate the layer 2 vulnerability identification and the usability of the security recommendation. So for the project scope, our system will focus on internal IP4 LAN and the layer 2 broadcast format. And the system will use the ARP-based host discovery to identify device connected to the same local network. And after discovering the host, the MAP is used for service detection, such as identifying open ports. And the system will also use the CVNS together with MVT or CB matching to support vulnerability risk assessment. And I'll move on to the chapter 2, which is the literature review. So for the literature review, I will focus on three existing vulnerability scanning tools, which are Nmap, Nexus, and OpenVLS. So the Nmap is a well-known open source network scanning tool, and it is commonly used for host discovery, port scanning, and service detection. And the Nexus is a commercial vulnerability scanner that provides detailed vulnerability detection, risk assessment, and reporting. And the third one is OpenVSS, which is an open source vulnerability assessment platform, and it provides a strong scanning and security evaluation function. So these are the comparison table of existing system versus our system. So the NMAP will support the host discovery and ports or service detection, and the Nexus and OpenVS will provide more complete vulnerability mapping, risk scoring, and remediation guidance. And the router logs can also provide some monitoring information, but they are limited because they do not really perform vulnerability mapping or risk scoring. So our system is designed to combine the important function into one lightweight system. So it will include host discovery, service detection, vulnerability mapping, risk scoring, and plain language remediation guidance. And next, I'll move on to chapter 3, which explains the system development methodology. So for this project, I will select the iterative and incremental development model. So this model is suitable for NetGuard because a network scanning system has several components that need to work together, such as host discovery, scanning, and so on. So the development process will include the requirements, design, development, testing, and review phase. So by following this approach, each part of the system can be tested and improved before moving to the next part. So this slide will show the main technology used for NEGA. So the Python is used for backend logic, automation, and scan results. And the Flash is used to build the lightweight dashboard and handle system routing. And MMAT is used as the scanning engine for host discovery, host scanning, and service detection. And the last one, SQLite is used as the local database to store scan results, vulnerabilities, and reports. So I'll move on to the chapter 4, which is the requirement analysis and design. So the slide is show the system architecture of our system. So the architecture will divide into three main layers. So the first layer is the presentation layer, and the second layer is the application logic layer, and the third layer is the data persistence layer. So this is our use case diagram for our system. ATP diagram show the flow of the network scanning process. And this slide will show the database design of our system through the entity relationship diagram. So the main table will include user, scan section, access, service, vulnerabilities, remediation, and audit logs. Okay, so this slide will show the prototype interface design for NEGA. So there are three main screens shown here. So which are the login page, security dashboard, and scan result page. So the login page will support the role-based access, and the security dashboard will give user an overview of the network security condition and scan control. And the scan result page will show more detailed finding and remediation advice. So this slide will show the page navigation design of NEGA. So the navigation will start from the login page, and after login, the user will enter the dashboard, and on the dashboard, the user can start a new scan. And after the scan, the user will be directed to the scan result page. So the user can view the remediation reports or download a PDF report. So next, move on to the chapter 5, which is conclusion. So for the achievement of project objective, the needs of software and non-expert users have been analyzed, especially in terms of understanding local network security risks. And the NetGuard system architecture has also been designed by integrating web dashboard, scanning engine, database, and risk assessment components. And besides that, the system modules has been branded. The host discovery, service detection, risk scoring, and so on. And for future network in PSM2, I'll continue by implementing the full NetGuard prototype using Python, Flash, MMAT, and SQLite. And after that, I'll connect the scanning result with CB and CBNS together with remediation recommendation. And I also plan to improve the system with features such as PDF report generation, scan history comparison, and schedule scanning.